Here in this presentation, we will consider solve problem 1 related to asymptotic analysis. So let's get started. What is the time complexity of the following program? The program is available in front of you. You need to determine the time complexity of this particular program. Here you can see this is not a complete program. Only a function is given in front of you. And let me tell you that this function accepts one argument, that is value for n. And within this function, we have these statements written over here. So you can clearly see that the first statement is I am declaring 3 variables and one more variable, and I have initialized this variable with value 0. This is a count variable which has been initialized with 0 value. Then we have these for loops which are basically nested for loops, and within this for loop we have the statement count plus plus. You need to determine the time complexity of this program. It would be better if you can pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. Now let's take this statement first. Here you can see I have declared 3 variables and one more variable count, which has been initialized to 0. These 3 variables haven't been initialized. We will use these 3 variables within this for loops. You can see the time complexity in this case is big of 1 because it's just taking a constant amount of time for the execution. There are no for loops, nothing special. You can treat this as a single statement. Although you can write these in multiple lines as well, but treat this as a single statement. If you treat them with different statements as well, then also it will take constant amount of time. Isn't that so? So this particular statement is just taking a constant amount of time. Now let's consider this particular statement. This is nothing but a for loop, right? Within this for loop, we have another for loop. And within this for loop, we have another for loop. Then we have this statement. Obviously, our task is to find how many times this particular statement has been executed. So let's first evaluate and try to understand what this for loop is and how much time it will take. In the iteration number 1, you can clearly see that I is equals to n by 2, right? You can write this as I equals to n by 2 plus 0. Now in the iteration number 2, it is clear that this will be I equals to n divided by 2 plus 1. Because you can clearly see over here that this is I plus plus, an increment by one step. So obviously in the next iteration, this will be n by 2 plus 1. In the iteration number 3, this will be n by 2 plus 2. In the iteration number 4, this will be n by 2 plus 3 and so on. Now let us assume that we are running up to iteration number k. In that case, I will be equal to n by 2 plus k minus 1. Here you can clearly see in the iteration number 1, this value is 0. Iteration number 2, this value is 1. While this n by 2 remains constant, only this value is changing with the iterations, right? In the iteration number 3, this will be 2. Iteration number 4, this is 3. So similarly, in the iteration number k as well, this will be k minus 1. So I will be n by 2 plus k minus 1, which is equal to n, because this is the last iteration we are considering. But we don't know how many times this has been executed. That's why I have taken this as k. So at this particular iteration, I is equals to n by 2 plus k minus 1, which is equal to n. Now let me rewrite this over here in a proper manner. This is n by 2 plus k minus 1 equal to n. Let's solve this. We can write this k minus 1 equals to n minus n by 2 without any problem. I can bring this n by 2 over here. By solving this, this becomes k minus 1 equal to 2n minus n divided by 2. Again, we can write this as k equals to n by 2 plus 1. This means that our loop is running n by 2 times. I can take the least upper bound as n without any problem. Loop executes n by 2 plus 1, which can be thought of as n by 2 times only, because plus 1, if we won't consider, then it will not cause any problem. We can take the least upper bound as n without any problem. So this loop is actually running n times. Although it is running n by 2 times, let me tell you, but we are taking the least upper bound without considering the constants. So least upper bound of n by 2 is obviously n. So we can say that this loop is running n times. So this is big O of n. Now let's consider the next loop. Here in this case, you have j equals to 1, and this is quite interesting. Here it is written j plus n divided by 2 less than or equal to n. And here it is just j plus plus. Let's see what is happening over here. In the iteration number 1, it is clear that j is equal to 1, right? In the iteration number 2, j is equals to 2. Iteration number 3, j is equals to 3. Iteration number 4, j is 4, and so on. At iteration number k, j will be equal to k without any problem, because here in iteration number 4, we have j equals to 4. Iteration number 3, we have j equals to 3. So it is clear that in iteration number k, j is equal to k, which is equal to n by 2. Why I am writing this as n by 2? J plus n by 2 less than or equal to n can be written as j less than or equal to n minus n by 2. I can bring this n by 2 over here. This becomes n minus n by 2. I can solve this and this brings me n by 2. So j is eventually less than or equal to n by 2. I can say that k is equal to n by 2 without any problem. So it is clear from this fact that this loop is running n by 2 times. I can take the upper bound as n and can clearly say that loop is running with the time complexity big O of n. So this is the upper bound I can take, which is n instead of n by 2. Always try to remove the constants. Don't take n by 2. Instead of n by 2, you can take a least upper bound. That could be n. Now, let's see the other loop. Here in this case, obviously, we can clearly understand that k is equal to 1 and k is less than or equal to n and k is equal to k into 2. We have already calculated the time complexity when these loops are available. Here in the iteration number 1, k is equal to 1. 1 can be written as 2 to the power 0, 2 can be written as 2 to the power 1. Similarly, 8 can be written as 2 to the power 3 and so on. If I consider this up to iteration number p, then this will be 2 to the power p minus 1, which is eventually equal to n. Because in the last iteration, 2 to the power p minus 1 is equal to n. You can clearly see over here. I can say that 2 to the power p minus 1 is equal to n or n is equal to 2 to the power p minus 1 without any problem. I can take log on both sides. This will become p minus 1 equal to log n base 2. I can write this as p equals to log n base 2 plus 1, which is equals to big O of log n. I can eliminate this constant. So I can say that the time complexity for this loop is big O of log n. Now let me tell you, these are nested for loops, right? So obviously you know that we need to multiply these three time complexities. N into log n, which is equals to big O of n square log n. So I can say that the time complexity for this particular code is big O of n square log n or order of n square log n. So this is the time complexity of this particular code. This loop is running n times. I have taken the upper bound. This loop is also running n times. Again, I have taken the upper bound. Here in this case, this loop runs log n times. This is nested for loop structure. So here in this case, we need to multiply these three time complexities. N into log n will give us n square log n, which is the final time complexity. This statement is executing n square log n times. So this is the time complexity of this particular code. Now here is one homework problem for you. The program is available in front of you. Again, we have three nested for loops. You need to determine the time complexity of this program. And obviously, you can post your answers in the comment section below. Okay friends, this is it for now. Thank you for watching this presentation.